In this video, we're going to take a quick look at inverse proportionality equations. So in the previous video, we saw direct proportion working, and if y was directly proportional to x, then we'd write the above. And the formula for would generally be y equals some value k x. Well, in this video, we're looking at inverse proportion, and that means as one of the variables goes up, the other one goes down. And as you can see below, we have a different thing to write here. We say y is directly proportional to 1 over x. That's going to help us see that as one thing goes up, the other thing goes down. So our proportionality equation is going to look very, very different. It's going to look like this. Y equals some value, the constant of proportionality, over x. Okay, so it's similar to the direct proportion, but we're going to be starting off with a new formula. Let's take a look at some examples to see if we can work out how to do this. So straight away, let's use our table here, and we can see that we've got to work out a formula first to relate x and y together. So we know that they're inversely proportional, so that means that the general formula will be y equals k over x. Now, already we can see that when x is 5, y is 12. So let's put some values in and see if we can generate that constant of proportionality k. Well, 12 is equal to k over 5. That's me swapping the numbers in. And now if I multiply both sides by 5, I'm going to get that 60 is equal to k. And now I can rewrite my formula for use, and that will be that y equals 60 over x. So now all we've got to do is keep using that formula to help us generate the rest of the values for my table. So in that left-hand side space, we know that x is 2, so y is going to be 60 over 2. Well, y is going to be 30. In that next space, we have x is 6, so y is going to be equal to 60 over 6. Well, that's 10. So that one is relatively straightforward too. In the final two spaces in the table, it's a little bit more tricky. We're given the y and have to find the x. So we know, for example, that y is 4. So 4 is equal to 60 over x. We're going to need to solve this equation in order to help us. So we could think about multiplying both sides by x and dividing both sides by 4. X is going to be 60 over 4, which is 15. Let's do that again with that final question. So we've got 3 is equal to 60 over x. Rearranging that equation gives us that x is 60 divided by 3. Well, that means that x is going to be 20. Okay, so in general, we're going to find that proportionality equation still, just like last time. It's going to look a little different, but then we're going to use that to solve some problems. Right, let's have a look at some worded examples now. In an electric circuit, the current I is inversely proportional to the resistance R of the circuit. So before we even get started, let's write this out. So I is proportional to 1 over R. And we know the proportionality equation is going to be I is equal to K over R. Right, let's carry on. So A, if when R is 1,000, I is 0.5, find that relationship between I and R. So we're going to put those numbers in. I is 0.5 when R is 1,000. So in order to find K, we're going to need to solve that equation. Let's times both sides by 1,000, and we should be able to work this out. So 0.5 times 1,000 is 500. So K is going to be 500 in order to make that work. And this leaves us with the proportionality equation I equals 500 over R. Okay, now let's move on to part B. If the resistance increases to 1,500, what is the current? Well, R is the resistance, so let's substitute that in. So I is equal to 500 divided by 1,500, that new R value. Now, if we work that out, okay, you can probably see already using fractions, I is going to be 1/3 or 0.3 reoccurring if we wanted it as a decimal, okay? So we've got our value there. C, what happens to I if R is doubled? Well, if we think about that previous example of being 1,500, well, if I doubled it and said, okay, well, I is equal to 500 over 3,000, that would give us I is a sixth. Now, what's going to be happening here is if we double our R value, you can see between a third and a sixth, we are halving our value of I. So that's our answer, okay? We can say that I is halved. And this is what inverse proportion is all about. As one thing goes up, the other one goes down. As we double one value, the other one is halved. Okay, final example now, and then you can do your exercise. The wavelength of sound waves is inversely proportional to their frequency. So let's stop there and say wavelength is W. And let's say that F is frequency. And if wavelength is inversely proportional to frequency, then W is directly proportional to 1 over F. And our general formula with a constant proportionality in it is W equals K over F. Right, let's read on. When the wavelength W is 0.25 meters, the frequency is 1,360 hertz. Find the frequency when the wavelength is 0.8. So we'll put those numbers in to our general formula and see if we can work out that constant of proportionality. So 0.25 will be equal to K over 1360. So in order to find out what K is, I'll need to do 0.25 times 1360. If I work that out, I get 340. So K is 340. So finishing this off, let's just write out that equation in final form. We can say W equals 340 over F. Now we're in a situation where we can answer these questions. So A, find the frequency if the wavelength is 0.8. Okay, well, let's put in 0.8 as our wavelength and try to solve this equation. If I multiply both sides by F and then divide by 0.8, I'm going to be left with F is equal to 340 divided by 0.8. And if I work that out, I'm going to get F is equal to 425 hertz. Let's do B. Find the wavelength if the frequency is 850. So let's find that out by subbing in F to be 850. That means the wavelength will be 340 divided by 850. So 340 divided by 850 is 0.4 meters. Okay, we're finished. Right, hopefully that's helped you to understand how to work with inverse proportionality equations.